This video is brought to you by Sonnos Automation, Systems and Control Services, Industrial and Pneumatic Parts, Consultations, and Systems Design. Dew point is defined as the atmospheric temperature below which water droplets begin to condense and dew can form. On the average, ambient dew point is usually within 13 to 16 degrees Celsius. Below this temperature, water will condense from air. This is the same principle used by aftercoolers. If you cool down hot air, it will be forced to condense water, thereby removing water from the compressed air. Aftercoolers. Aftercoolers are heat exchangers for cooling the discharge from an air compressor. They use either air or water, and are an effective means of removing moisture from compressed air. Aftercoolers reduce the amount of water vapor in a compressed air system by condensing the water vapor into liquid form. Aftercoolers combined with a separator are an excellent way to reduce moisture in a compressed air system. In a distribution or process manufacturing system, liquid water causes significant damage to equipment. An aftercooler is necessary to ensure the proper functionality of pneumatic or air handling devices that are a part of process manufacturing systems. Aftercoolers can use either air-cool or water-cool mechanisms. Air-cooled aftercoolers. This type of aftercooler uses ambient air to cool the outlet compressed air from the compressor to a temperature of only 10 degrees Celsius higher than the ambient temperature. This cooling causes condensation of up to 80% of the moisture in the compressed air. The condensate is then gathered and discharged in a cyclone filter. Installed at the aftercooler outlet. This aftercoolers are made up from a heat exchanger with finned coils cooled by a high-efficiency axial fan mounted on a galvanized and painted sheet structure. Water-cooled aftercoolers, usually constructed with a steel shell and copper tubes, as shown in the following figure. As hot compressed air flows through the tubes of a water-cooled aftercooler, the cooling water flows on the outside of the tubes in the opposite direction. This countercurrent arrangement makes the tube walls progressively colder for maximum cooling efficiency. Heat from the compressed air is transferred throughout the tube walls to the water, thereby reducing the air temperature steadily until the dew point is reached. Cooling causes the vapor to condense on the tube walls, forming water droplets, thus reducing the water vapor content of the compressed air. End of Lesson 4.